And now we're actually at the point where we're ready to do our analysis. So when we do our analysis, typically I recommend starting on the derivative plot. In PTA, essentially, we're going to see all the flow regimes that we've encountered during this test period. So depending on how long they flowed the well for and how long they've shut it in for, that pressure response will reflect all of the flow regimes that pressure transient has encountered during the test. So so what we're looking for here is we're looking for these various flow regimes. And this wizard here, we've organized these by order in which they typically occur in the reservoir. So for example, you'll notice the very first option here says wellbore storage, okay? And you'll notice a number in parentheses next to that. And that number indicates the slope we're expecting to see on the derivative plot. So wellbore storage will appear as a unit slope on your derivative plot. So that is what we're looking for. Okay, so if I actually want to analyze that part of my derivative, what I would do is I would click on this wellbore storage button, and it will put a wellbore storage analysis line on my derivative plot. And that line also comes with an annotation, and this annotation will give me an idea of how much storage I'm dealing with. So the CD value, which stands for dimensionless wellbore storage, represents how much wellbore storage I have in this particular well. These lines can be expanded or reduced just by simply clicking on the third point here, the final point, and just dragging the line either out this way or back this way, okay? So what we're trying to determine is where that wellbore storage kind of ends. And usually I drag it a little bit past where it ends here so you can start to see the deviation from wellbore storage. Okay? And we're going to repeat the same process throughout the derivative response here. So what we're looking at is we're looking at these red triangles here. That represents our derivative. That's what we're analyzing. The blue circles here just representing our delta psi over Q, or our pressure difference, our normalized pressure difference. And typically, but what we're trying to do is just focus on the derivative here. This is really just for additional information here, this normalized pseudo pressure difference here. But essentially, as we're doing our analysis, we're going to be focusing in on this, which is basically a magnification of that pressure response there. As we continue to move through the derivative here, you'll notice there's a hump here. And I'll talk about this a little more once we get into modeling, but essentially that is an indication of near wellbore damage. So the larger the hump we see here and the bigger drop down here, the more skin damage we've got or we're dealing with in this well. Now in order to determine skin and also permeability, which I'm going to be getting into in a second here, we need to do what's called a radial analysis on that. So if I move through my list here, I'll find that I have another analysis line type with a 0 next to it that's called radial. Okay, so I'm going to click on that option, and that's going to put a radial line on my plot. And again, I'm going to position that over where I'm seeing a horizontal slope or a 0 slope. Okay. Now I've kind of glossed over some of these other flow regimes here that are between wellbore storage and radial. We actually don't see these in this particular pressure response. We would see bilinear or linear fracture flow if we were dealing with a hydraulically fractured well. In this case, this well was not hydraulically fractured, so we don't expect to see those flow regimes, and we actually don't in this pressure response. So I'm not ignoring them, but there's a reason why I've kind of skipped over those. Spherical flow is really a specialized flow that occurs in partially penetrated wells. And again, we're not dealing with a partially penetrated well here, and this demo isn't going to cover the specifics of that, but all you need to know for this particular example is we're really only seeing wellbore storage and radial flow in this one. And this is probably for most conventional type well tests, such as this one, that aren't fractured, these are the two flow regimes you're going to see probably 90 to 95% of the time. Like I said, you'll only see these other flow regimes if you're dealing with fractured wells or partially penetrated wells. So moving on with our analysis here, I position my radial line over what I believe to be is the radial flow portion of this data. Notice we're seeing a little bit of fluctuation in the data here. That could be some wellbore effect, or it could be a reservoir effect. So one of the things that we're going to do to try and figure out whether we're seeing wellbore effects there is we're going to use another piece of information called the PPD. So to show that, I'm going to right click over the plot and I'm going to select Show PPD Data. That's going to add another data set to the plot here. And essentially the way the PPD works is we're looking for a continuous decline in that data set, and that for the most part we're seeing that. Near the end we do see it increase a little bit. Whenever we see an increase in the PPD, that's a sign that we've got wellbore effects happening. So essentially what this is telling me is that these fluctuations in the derivative we're seeing here do appear to be some kind of wellbore effects. And if they're wellbore effects, they're not reservoir effects. So we can essentially try and ignore those wellbore effects. So we're going to try and fit our line over through that anomaly there. So it looks like we've got a good trend here initially into radial flow, and then it starts to fall apart due to the wellbore effects. If these wellbore effects didn't happen, this trend would most likely continue to follow that horizontal line. So I'm just going to position that where I think where I believe that radial flow is happening. So I'm going to position my line right there. Okay, I'm going to go back to the semi-log plot now. So I'm just going to minimize that. I'm going to maximize my radial or semi-log plot. And you'll notice there's a radial line on this plot now. So this plot is what we call a specialized plot. Its main purpose is to analyze just radial flow. Okay? We have several other specialized plots you can choose from here. We have plots to analyze bilinear flow, linear fracture flow, spherical flow, various other flow regimes. In this case we're not dealing with those, so I'm not going to use those, but just so you're aware, those options are available to you if you're dealing with those specific flow regimes. So this plot will let me kind of focus in on radial flow here. So one of the things I can do here is, rather than just moving the line around to where I think radial flow is I can actually do a best fit through the data that I believe is radial flow. So the way I do that is I'm going to select my line, and you notice the line turns black. That means that line's selected. I can either click on the line or I can click on the annotation that's attached to that line. Either way, you'll notice it selects the annotation in the line, or they're highlighted in black. And then what I can do is I can go to my selection tool here, and just like we saw in the production editor when I was spraying points, we're going to do the same thing here. I'm going to hit my select points option, and I'm going to spray my last few points here. You notice it's going to snap that line through the points I've selected, so it's done a best fit through those points. And again, I can position my annotation maybe closer to the line, so that when I print this plot out, it looks a little more tied to the line. Just do a quick print preview on that so you can see what that's going to look like in the printout. And again, that's really all there is to the analysis portion. So we've basically identified our wellbore storage and our radial flow. And our radial flow, if I go back to the derivative now for a second, is going to give us estimates for permeability and skin damage, as well as our extrapolated reservoir pressure. So all of these things we're going to use in the modeling section to try and get a better understanding of what the characteristics of this reservoir are. Before I move on, I'm just going to make one minor change here, just a cosmetic change. If I go up to the tab here, I'm going to right click on that tab, and just like we did in the data management module, I'm just going to rename this tab. I'm just going to remove the number 1 off that. So it's just called diagnostic analysis. Again, just for clarity's sake and just to clean things up. Okay, so now that we've gone through our analysis, I'm going to move on to the modeling portion. Now, for whatever reason you do get confused in the analysis, or you need a little more information on these specific analyses line types, there's a show example button next to all of these. So for example, if I click on this show example that's next to wellbore storage, that is going to open up our help. And I'm just going to shrink this window down here so you can see it. That is going to take you to that specific part of the help file. Okay, so this would just cover wellbore storage analysis. So it gives you a basic rundown of all the equations that are used, some of the information on the theory, and a summary of the equations for both gas and oil. And it covers both the specialized analysis plot as well as the derivative analysis. Okay. So again, if I were to click Show Example on the radial, that will take me to that part now. So now I'm in the radial flow analysis section of the help. So this just gives you a quick summary of what equations are being used to calculate these values you're seeing, and also if you need a quick review of some of the theory in order to just get a better understanding of what the software is doing or what you're trying to accomplish here, those are available to you.